Finding a confidence interval for a difference between two means follows a very similar process to everything we've done so far. Our sample statistic now is x1 bar minus x2 bar, and our margin of error is calculated by the formula t star times SE, just like it was for one mean. Only now we're using the standard error formula that we established previously, or we're using the applets to calculate it for us. So we're getting our standard error by a different method, but otherwise our margin of error follows the same basic formula. And t star is a critical value for the t density curve, or the t distribution with n minus 1 degrees of freedom. So we get this from table A. We could also get it from software, but our confidence intervals we usually get from table A because the numbers fall right in the table. So we'll estimate with 90% confidence. We're going down to 90% for this just because our statistical significance was not very strong. So we'll estimate with 90% confidence the difference in mean BMI among smokers and non-smokers in our population of interest. So first, let's recall a few details we already established. First, our x bar for non-smokers minus x bar for smokers was 1.694. Also, our standard error of this difference of means, which we got from the applet, is 0.8370. For a difference between two means, we use the same standard error formula as we used for a hypothesis test. This is not true for proportions. There's that distinction between the pooled proportion and the individual sample proportions. But it is true for means. This is just a simple formula that takes into account the sample sizes and the standard deviations of each sample. So we don't have to look this up a second time. Now let's go ahead and look up our t star critical value. Remember that we have 90% confidence here and 42 degrees of freedom, which we got from our smaller sample being of size 43. The conservative degrees of freedom, we take the smaller of the two ends and subtract 1. So I'm going into my critical values table here and looking at the 90% column, and I can see that I'm really interested in here down to 40 through 44 degrees of freedom. As the critical values start to get closer together, we look at ranges of degrees of freedom instead of precise values, and I will take the first one there, which is that 1.684, since it's in the 90% column. So 1.684, coincidentally kind of close to my sample statistic of 1.694, but those two of course aren't related at all. And now we can put together our confidence interval with the sample statistic x sub n bar minus x sub y bar plus or minus the margin of error, where of course the margin of error I calculate as t star times the standard error, which is simply 1.684 times 0.837. I get 1.4095, which rounds up to 1.410. So for my confidence interval, I will center this at 1.694, add and subtract the margin of error 1.410 to get the two boundaries. Subtracting gives me a lower bound of, we can round these off a little bit too. Let's go ahead and, instead of carrying all these digits around, Let's go ahead and change that to simply 1.7 and 1.4. Which will give me a lower bound of 0.3 and an upper bound of 3.1. Now, of course, we still need to interpret this confidence interval. So we start that out with 90% confidence. Almost said 95%. With 90% confidence. And I want to think about what I'm saying here. It looks like the mean BMI or Quetelet index for non-smokers is higher than the mean Quetelet index for smokers, which we can tell by the fact that the entire interval is positive, and we are subtracting in the direction of non-smoker minus smoker. So mean Quetelet index is higher among non-smokers than among smokers by somewhere around this amount, something between 0.3 and 3.1, where the units are the units of the Quetelet index, which is, we'll just call it points, because it doesn't really have a more specific unit than that. So we will say that with 90% confidence, mean Quetelet index, or we could say mean BMI, for non-smokers is between 0.3 and 3.1 points higher than for smokers. Make sure that your interpretation of a confidence interval for a difference of means does indicate which group has the higher quantity and expresses the numbers as a measure of how much higher one of these groups is than the other. Also, make sure to include the word mean. We're not saying that each individual's Quetelet index is going to be this much higher than another individual's Quetelet index. It really is just a statement about averages.